The SD Ruby podcast is brought to you by New Relic.
Good evening. Good evening. So I talked last month about Postgres, and I've sort of often interjected about Postgres, so I thought I'd, over the next couple of meetings, if I haven't lost you, try and give you some details about why I tend to prefer Postgres. So tonight, if you're currently a MySQL user, maybe I can give you some reasons you might consider switching to Postgres. And also, I think if you're a Postgres user but you haven't really got your black belt yet, maybe I can present you with a few of the features of Postgres that are really a step above what's available in MySQL that can make your life a lot easier as a developer. If you're following along at home, feel free to hit up the presentation which is up on the slideshow at the moment. It may make it easier reading some of the code. I've tried to make it reasonably readable, but that might be a slightly easier option for you. You see what that says? Okay. So to begin with the simpler stuff, first of all, Postgres has a considerably larger type zoo than MySQL. MySQL pretty much has dates, strings, blobs, and numbers. Postgres has a real Boolean. I know, right? Worst design decision in all of the many poor design decisions in MySQL is that it doesn't actually have a Boolean type. The Postgres numeric type is richer. There is, for example, a much larger high accuracy number available in Postgres. Has a native representation for network addresses with suitable functions and operators on them. Has UUID as a native type, it has XML as a native type, and I know XML functions are available in MySQL, but it's nicer to have the native type so that you can get your types correct when you're calling functions and so on. Similarly, there are built-in geometric types. So when I say the types, these are all column types you can have in Postgres. And in 9.2, which is in late release candidate status about now, I think, JSON is going to be a built-in type. So that's nice, but how about this? Here's a programming language where you can define your own structured data types. Right? Yeah? Pretty much the same sort of thing you can do in any programming language. You can define your data type as composed of other data types, and these can be the type for fields. You can assign them to variables and so on. Postgres has very sophisticated indexing capabilities, so you'll have no trouble searching on these using indexes or anything it is you might need. Now this is kind of a Mickey Mouse example, but I was on a project that was doing a sort of a popularity graph computation exercise, you know, Netflix sort of deal, and it was based on a mathematical theory that had these various types of support vectors and various other sorts of things. What we were able to do in this project is make those first-class types in Postgres, which really made dealing with them an awful lot easier than it would have been in something in MySQL where I was trying to deal with, you know, a set of columns or a bunch of related fields from my main type. I could just have a support vector field in the database. To go along with that, Postgres lets you define your own functions. Now I know technically you can define functions and stored procedures and triggers and things in MySQL, but the programming language in MySQL is appallingly bad. I mean, it's really, I'd rather use COBOL. Whereas the programming language in Postgres is basically the same one that Oracle has. And if you don't like the one, and it works quite well for its purpose, and if you don't like this, there's ways of using a whole lot of other programming languages. One thing worth mentioning in particular is that if you're doing statistics, you can install R as a first-class programming language in Postgres, and it can't be any better way on earth of doing statistics than having R built into your actual database engine. Speaking of statistics and functions, in general in Postgres, in any area, Postgres will have more functions and more operators, more batteries included than MySQL does. So there's a fairly reasonable set of statistical functions, and the selection in MySQL is about half as many. Back in the dark old days, 3 or 4 years ago, Postgres didn't have a text search capability built into it, and MySQL does, so people used MySQL at that time because of its text search capabilities. But now, Postgres has a very sophisticated text search engine that comes built in that really can give the likes of Lucene and Solr a run for their money. It does all the kinds of things you'd want in a sophisticated text indexing system, including you can plug in other languages, you can add your own dictionaries, you can do all the kinds of sophisticated searches that you might normally want to use Lucene for. And being able to do that in the same database where you're also searching on dates and whatever else you happen to need makes your life an awful lot easier as a developer, not to mention gives you the results a lot faster and with a lot fewer systems to set up. MySQL pretty much just gives you a few basic text functions. It can use an index to make them run reasonably quickly, but it won't do standing stock words and these other things that you might want if you're really serious about doing text. Postgres has a part of the SQL standard called window functions, which are simply not available at all in MySQL. If you're not familiar with them, what they do is they let you perform group by calculations, but leaving all the original rows intact. So, to give you an example, you can use any regular aggregate function as a window function. So in this case, this over partition by part of the syntax here that comes after the average function means that this will display just your regular list of all your users that you're selecting from that table, but it allows you to divide their individual salaries by the results of this aggregate function. Now to do that in MySQL, you'd need to use a subquery, which is going to make certainly a lot longer, more complex query, even in this simple case, let alone if you're trying to do anything complicated. And by the way, MySQL's query optimizer is wretched, so if you're doing any amount of subqueries in a query in MySQL, it'll probably fall on its face. There are also special purpose window functions that allow you to do things like, in this case, find the sequence of the order that someone appears in the table ordered by hire date. So this will give you they were hire number 1 in that department, hire number 2 in that department, hire number 3 in that department. I don't think you even can do that in MySQL. And even if you could, the SQL to do it would be absolutely appalling. What you will do is pull the results into Ruby and calculate the row numbers yourself. So it's nice being able to do all that stuff right in the database. They're not that hard to learn to use, and you're really getting close to having your red belt in SQL if you start learning to use the window function. Another thing that's really going to make your life an awful lot easier in Postgres over a database that doesn't have them. By the way, most of these features are also available in Oracle and SQL Server, if that's what you're using, is a common table expression, which I don't know if you've ever tried to do a very large, complicated query, and in order to break it up so that it doesn't have 17 nested subqueries, you turn some of them into views, or, I don't know, just learn to deal with it. This will let you pull those out within that one query and give them a name and separate them. You can also do it with other parts of the SQL command like an insert or a delete. So to give you an example here, on the left-hand side you'll see two common table expressions. The top one is with regional sales as. That's basically defining a local view for this query. And then below that is top regions as, which defines another view for this query that pulls out of the first one. And then over here on the right, we're able to write a nice simple bit of SQL. It's very easy to read and write, for that matter. In MySQL, this would have to be a select with a select inside it, with a select inside that, and with a select inside that, which will make MySQL fall on its face, and you won't be able to write it, let alone read it. So that's terrific, and if that was all common table expressions let you do, I say that would be a tremendous win. But another thing that you can do with common table expressions is recursive queries. So this is a kind of ultimate simple case, but it's much like writing a recursive function in another programming language. You'll generally have one or more, probably two cases with a union or union all in between. Generally, you'll have one that's just returns a set of starter values, values bracket 1 in this case, and then union, and then another select statement that draws from this whole thing and has a stop condition on it. So this will print out all the numbers from 1 to 100, which is kind of a Mickey Mouse example. So let's look at one that's a bit less Mickey Mouse. If you have a database that has a graph of some kind in it, this will let you walk that graph, given it, you pass it in a starting node, it will walk the graph, finding everything connected to that original node. Worth pointing out, you could put a limit on that last select if you only want to some subset of the graph. But as you see, you've got a starting condition. We return the original node that was passed in and a 1, which is our depth count. And then we have a recursive condition, which returns some value derived from what we found so far, and then has a stop condition, which is basically going to be when we run out of length. Now, if you look at that, you'll see that that's not going to work for a graph with any kind of cycles in it. That will make your database server instead melt into a puddle of molten metal on the floor. But we can easily add some extra logic that will make it deal with cycles just fine. The way you do this in the regular programming languages, you probably pass around an array or a set of nodes you visited so far, and as you visit a node, you check whether the node you're visiting is in the list of nodes you've already seen. And you can do exactly the same thing in Postgres. So this is much like the previous one, except we're handing around 2 more columns. Path, which is the nodes we've visited so far, and cycle, which is a Boolean condition as to whether we've run into a node we've seen before. And then we can use arrays. That creates an array in line. This is an array concatenation operator, and that's a function that tells you whether an element of an array is equal, the item on the left is equal to any element in the array. So it makes it fairly easy to write something like this that does graph walking. In my experience, an awful lot of developers avoid using recursive relations on tables and databases because you can't. But with common table expressions you can, and it's not that hard to do when you get used to it. You can also use common table expressions to make your life easier when you're modifying data. So here we want to pull some rows out of one table and put them into another table. So we have the delete part of that is a common table expression at the top that returns the rows that were found, that were deleted. And then in the bottom, we use the results of that to insert them into a different table. Now you can do this with standard SQL just fine, but the way you do it in standard SQL is with 2 statements, one which does the select and insert into, the other one does the delete. This is more concise and drier because you'll note, for example, that the condition that identifies the rows that we're moving is only presented once. So it's more concise and it's easier to read. You can do a whole sequence of these, and also this is particularly useful if you want to reuse some results that are generated in the database. So if I want to insert some rows into one table which are going to generate values in the database, sequence numbers, random numbers, timestamps, it'll allow me to do that in one part of my SQL statement, return those values and then reuse them again in another one. So it allows you, rather than sending some stuff over the wire to the database, doing a query to get what it did, and then sending it back over the wire again to the database, you can do it all boom in one go. There are some smaller, simple features to describe in Postgres that drive me up the wall when I have to work with MySQL because they're not available. One is that you can index in the background. You can give a version of the index command that will not lock the table. So you could have hundreds of millions of rows and you want to add an index to it, and Postgres will quietly do it in the background. It'll take a while, but you can still query and insert into the table while it's happening. Another good one is that in Postgres, schema changes can happen in a transaction, and Rails will do this for you when you run a migration. So I have to confess that occasionally when I'm writing a migration, I will make a mistake. Invariably when I do, it's near the end of the migration. And when it's in my MySQL database, I now have to go back and repair my database and curse a lot. But in Postgres, I just fix the migration and run it again. Because adding tables, adding columns, changing column definitions anything you might want to do in the way of a schema change in Postgres can happen in a transaction. Postgres also can do very fast schema changes because it does them in a sort of lazy fashion. So you can drop a column on your table with hundreds of millions of rows, and you say, drop the column, and it says, yes, what would you like me to do next? If you want to, you can also compact the table afterwards. But it's nice that you don't have to. Similarly, you can add a column, unless it has a non-null default value. It will say, fine, what would you like me to do next? There are some other features that Postgres has that are in the same sort of realm as NoSQL. So let me say something about NoSQL. As I understand it, people use the what you might call SOFA-oriented databases. They give a couple of reasons for why they do that. The one I've heard is that the SOFA-oriented databases will scale better than a regular database. I don't buy that because when White Pages and Skype and IMDb can all use Postgres, and when Twitter can store all their tweets in MySQL, I just don't buy that you need to be using one of these other newer, less tested, less flexible technologies. The other reason I hear for people using SOFA-oriented databases, and this is more reasonable, is that they don't have to deal with the rigid schema that you're required to have in a SQL database. And that, as I say, I think is a reasonable criticism, particularly of MySQL. The SQL databases are implementing what's called a relational algebra, but they do it very badly. The programming language resembles nothing more than COBOL. It's horrible, and I can't do anything about that. But also schema changes and schema definitions are sort of global and simple and very heavyweight. You ought to be able to have a table as the data of a field in a proper relational database, but we don't have that in MySQL. Defining a table is very heavyweight and so on. So I can understand why people use these more sort of flexible document types data stores, but they give up so much in doing that. That SQL databases give us. And with Postgres, you may not need to do that even if you want to get those flexibilities. One thing I showed you in an earlier example is arrays. In Postgres, arrays are a first-class citizen. They can be field values and variable values, and you can do anything with them you might expect to be able to do with arrays in most programming languages. So for example, in this, up here you can see I've got paid by quarter as an array of integers. Schedule is a two-dimensional array of text. You can insert into that using fairly simple, straightforward sort of syntax. Get the values back out again. You can pull apart those values as you're pulling them out of the database or in conditions in your query. You can slice your two-dimensional arrays to pull out different parts of them and use those in comparisons and so on in your queries. And Postgres has phenomenally sophisticated indexing capabilities. You can define indexes on these arrays that will get used in this type of query and give you good results. And also, as compared to how you would do the same sort of thing in something like MySQL, what you're doing here, other than probably making the code simpler, is all of those values are in the same row in the database. You're not having to do a join to go get them. So depending on what you're doing, this may well perform considerably better. All of that said, you won't, in practice, in most uses, normally have a lot of array fields in your database. But the kind of thing that makes arrays really great is when you use them in queries to simplify your life. So this is an example of doing something that's more or less the opposite of what those window functions did that I showed you. This array ag, when you're doing an aggregation, when you're doing an order by, group by, that lets you sort of roll up the individual field values that you're in the groups that you're aggregating on and pull them up into the individual rows. So it's sort of the opposite of what the window functions do. They let you keep individual rows and then grab an aggregate, pull it into those rows. Array ag lets you do this, and it's often useful, for example, to make a view that looks like this, where you can quickly pull out a summary of your data, but you can still do things like search for dates on individual values that were hidden by the group by. So if you want to get your red belt in SQL and you're using Postgres, array functions are tremendously useful. Now, if I'm going to claim that Postgres gives you features that mean you don't usually need a NoSQL solution, there's another data type we're going to have. Anybody? What's the sort of defining data structure in a NoSQL database? It's a key value store, right? Postgres has a plugin which comes included with Postgres. It's not hard to install, called HStore, that gives you key value as a primitive data type in Postgres. So you can have an HStore, a key value store, as the value of a field in Postgres, and there are operations that will let you pull it apart and query on whether particular fields in it have particular values. There's a plugin for Gem for Postgres that makes this all pretty transparent to use from within Rails. Am I right in thinking in Rails, is it they're going to have built-in support for HStore? Yeah. So it seems as though the Rails people have all pretty much bought into Postgres as the default best data store for Rails. So if you have an HStore field, you can do all kinds of things you might imagine you would want to do in your SOFA-oriented database. So I can reach into my key values and look for particular values, or I can look for substrings in those values, all that sort of thing. Probably the only significant limitation you're going to find using HStore as opposed to a SOFA-oriented database is that these are only key values as strings. You can't nest the values. But there would be ways of using joins to get around that in most cases. Finally, I mentioned in passing that you can install other programming languages. You can actually install, I think there are now up to somewhere near 20 programming languages available for Postgres. When I say you can install them, what I mean is they become first-class programming languages, and once they're installed, you don't need to use PL, PG, SQL at all. You can write stored procedures, triggers, functions, the works in Ruby, shell script, Scheme, Java. I mean, name a major Perl, name a major programming language, and you can use it as your programming language within Postgres. So if you have some procedure you're running at the moment that needs to crunch an awful lot of data, and it's written in Ruby and it pulls a whole lot of data off the server, crunches it, and writes it back again, try installing the PL Ruby programming language, and with some minor changes, you should be able to run it on the database server, and I guarantee you it'll run at least an order of magnitude faster.
Have COBOL?
I don't know that they do. It wouldn't surprise me if someone maybe has done it. There are some third-party sort of ones that aren't officially listed, but I haven't seen that one. That was a joke. So that was it.